Hello, this is going to be all about blockchain, and it is a blockchain Python tutorial part 1. Now, blockchain is the technology which Bitcoin uses. This is not about Bitcoin or any cryptocurrency, and as you can see from the picture, I'm not the greatest fan of hoarding wealth. I think money, wealth should be shared a bit more evenly. So I'm not really going to get into how to get rich, how to make lots of money, because that's not the point of this tutorial, and really that's not what I believe in. So we've all got our own opinions, so we'll leave that there, and let's just consider what is Bitcoin. So Bitcoin is a distributed peer-to-peer digital currency. Now, it uses blockchain technology, so let's just have a look at some code. Straight away we're getting into code. So a blockchain is a growing list of records called blocks that are linked together using cryptography. Each block contains a cryptographic hash of the previous block, a timestamp, and transaction data. So let's just think about those three things. We've got a cryptographic, can't even say it, a cryptographic hash of the previous block. You're probably thinking, what the hell does that mean? We'll get to that shortly. Timestamp, well, anyone familiar with databases or just code in general will know that a timestamp is basically today's date, hours, seconds, minutes, and so on. So there we go. What we've actually got here is an example of how we can hash. In fact, we're actually hashing it twice because hashes in the Bitcoin protocol are typically computed twice. There's a reason for that, and it's all to do with line 19, something called the length extension pack. So what we're going to do is we're going to look quickly at how we can do a hash. What is a hash? Date time, actually you can already see down there, date time. So a timestamp, first timestamp. With blockchains, it's called the first time you start the blockchain, or when you start the blockchain, it's often, you may hear it called Genesis. So that's the first timestamp and the block within the blockchain. Now blockchain is basically a chain of blocks. No, I'm being a bit flippant there, but we'll get to all that in due course. So this video really is actually, so I'm just drinking my tea. This video really is a look at what we need to consider, what we need to investigate and read up on so that we can become more knowledgeable about blockchain. And we'll look at some bits of code that I've already done, just testing the water, so to speak. And at the end, we will actually run the code which creates blocks, and it will add the previous block to the current block, it will timestamp it, and then it will create a hash of it. Hash is a funny word. In English, if you make a hash of something, it actually means you make a mess of it. But I can understand hash, not the thing that people smoke. Hash is one-way encryption. So it takes something which is readable, or it takes some bytes, and it converts it into something which is non-reversible. You can't reverse a hash. You can compare hashes. So if you've got a string of text or a number and you create a hash of it, a day later do the same thing, and the result will still be the same. So a hash of ABC will always be equal to whatever. If you modify it from ABC to ABD, the hash will be completely different. So by changing the slightest part of your input, your data, the hash is unrecognizable from the previous version. And therein lies its strength. If you've not already looked at one of my recent videos, I was talking about prime numbers, and anything to do with cryptography and hashing, etc., relies quite heavily on prime numbers. The most common hash at the moment, as of 2021 September, is SHA-256, secure hashing algorithm. Again, I'm not a subject matter expert on any of this, so really I'm doing this video to highlight or bring to your attention the various parts involved in blockchains, coding blockchains, or coding a blockchain. And obviously we will refer to the Bitcoin wiki because it is where it all started from. So, well, I say it all started from a man called Satoshi Nakamoto gets the credit for this. Although, however, I have read that somebody also did something quite similar in 1998. So we're not going to get into all that really. That's beyond the scope of this video. There we go. Does Bitcoin guarantee an influx of free money? Since Bitcoin is a new technology, what it is and how it works may be initially unclear. Bitcoin is sometimes presented as being one of these things, sort of online get rich quick scam, a loophole in the market economy, a sure investment that will almost certainly yield profit. I'm not even going to get into kind of the ethics and the morality of Bitcoin and cryptocurrency. Personally, I think the current fiat money system is flawed and it transfers wealth from the masses to the super rich. And if you read about inflation, inflation is basically taking money out of our pockets every single day. And if you want to read about the gold standard, which was stopped in 1971, from everything I've ever read, that is the cause of much of the transfer of wealth, shall we say. I believe there's a website, I've not actually looked at it, it's called What WTF Happened in 1971. Is there a website actually called? I was told there was a website called WTF 1971. .money, there we go. So if you're interested in money, from kind of a philosophical view or educational rather than just greed, have a look at this. Obviously, there's always the people who have got vested interests. So if somebody's trying to promote crypto, they'll obviously be highly critical of the current financial system. But then again, why not? If anybody's got savings, I don't know what the interest rate in your country is, but it's not great, is it? There's no point trying to save money anymore. And what the super rich do is they buy assets, so they buy property, they buy gold. But most of us can't afford to buy property or gold in any great amount. So anyway, let's have a look at some code. There's a thing called the hashlib in Python. So this is on my GitHub page. So I've created a new repo, blockchain. This is part one, and let's just test this code. It should just create a hash. So fundamental to Bitcoin, oh, sorry, I said Bitcoin. Fundamental to a blockchain and all things blockchain is the hash. So let's just have a little experiment with a hash. Oh, come on, is it still loading? I don't know. Apologies for recording this using Windows. I'm aware that I get a kind of a flickering screen when I record using Linux. I don't know why that is. I suspect it's probably because NVIDIA have got some kind of hold, or sorry, Microsoft have probably got some deal with NVIDIA that means you get inferior drivers on Linux or open source drivers because they're trying to protect their intellectual property. I'm getting tied in. Okay, import hash D. So what we've got here is, let's just save it. And hash 1.py. Something's running very slow today. I don't know if it's because video's recording and it's slowing it. Anyway, import hash lib. Then we create a variable D, and effectively that is, we convert a string, that's our input, we convert it into bytes, and then we perform the SHA-256 hash on it, and then also we create an empty hash. So D2 is a hash of effectively nothing. It still creates a hash though. And then hex digest. What is hex digest, I hear? Let's just run this and then we'll come back to hex digest. This firing up conda. Run it again. And there you see, there we have the output. So we're printing the digest of the hash and we're getting this long output of bytes. So something's happened. Let's just change hello to hello 1, and I'll just show you how utterly different the hash now is. Yeah, don't be mistaken. It hasn't suddenly turned it into a Python dictionary. That's just a stray curly brace on the end. Let's change it to hello X. And there we see. So every time so if we take off the X, you'll see that the hash should then go back to being ending in x83 equals P. And there we go. So it's what's called deterministic, which actually means there's no randomness involved. So every time you run this, you will get the same output for any given input. So identical input will give you identical output. Okay, so, oh yeah, digest. Let's just read about what the digest is. So hex digest. So I hope this is a bit different to a normal sort of short format tutorial, but I just thought we'd just run through this and kind of learn as we go, so to speak. There are plenty of tutorials which kind of 15 minutes long and then they just bang, 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 that's your tutorial. So I just thought we'd just explore some things. And yeah, the actual digest is a really big number. It's conventionally represented as a sequence of hex digits. So we humans aren't very good at dealing with numbers with more than a handful of digits. And hex has the advantage that it reveals some types of binary patterns really well. Let's just zoom in on that. For example, you'd be hard pressed to reason about a number like 4, 2, 6, 2, 7, 8, 9, 1, 2, 0, whereas its hex representation, FE150000, readily reveals that the low 16 bits are all zeros. But the object is more than just a number. It's a class instance with methods which allow you, e.g., to add more data in chunks so that you can calculate the digest of a large file or stream of data successfully without keeping all of it in memory. So there we go, that's the benefit. You can think of the digest object as a collection of states which permit this operation to be repeated many times, and the hex digest method as a way to query its state at the current point in the input stream. There we go. So I don't think I don't think it's essential with what we're doing as a kind of a demo, but let's just right, before we get too far, let's read up about hashes because I've kind of just glossed over them so far. So let's read the documentation about hashes. Usually when a hash is computed within Bitcoin, it's computed twice. Yeah, so that's the code that I've just shown you and demonstrated in VS Code. Most of the time, SHA-256 hashes are used. So yeah, they've double encoded hello, so okay. Not really a great description of hashes as such. It's just what is a hash? A hash is a function that converts an input of letters and numbers into an encrypted output of a fixed length. A hash is created using an algorithm and is essential to blockchain management. That's something else altogether. We'll move swiftly on. So we've briefly looked at what Bitcoin is. It's a cryptocurrency that uses blockchain technology. We've briefly looked at hashes. We've demonstrated creating a hash or a double hash even using Python. We've looked at timestamps. So timestamp is the date and its current date and time, which is then, that's actually a string. So you can then you can do what you need to with it. Okay, so what's next? I'm just going to go back to a previous example, and this is actually the full code, which I haven't written from scratch. Disclaimer, I've got it from, where did I get it? If we go back to the first bit of code, I don't know if I okay, I'll mention where I got that from in a minute, but yeah, this was my very first piece of code. So this is using object-oriented programming, so OOP within Python. So you create a class, you create a constructor, which is your init method, you pass it self, which is always the first argument, and then previous block. So yeah, the whole point of the blockchain is that you keep passing the previous block to the current block and it keeps getting bigger and bigger and bigger. So block 0, create an instance of the class block. Block 1 is block 0 plus the current block. Well, that's what we will need it to be. And then block 2 will be block 1, which in block 1 is based on block 0. So it keeps on, yeah, it's a chain. It's a chain of blocks. Right, okay, so let's have a look at this. I just need to find out where I got this code from. And I know why I've kind of plagiarized this. This was on medium.com. Let me just find medium.com. I'll put it in here. Medium.com blockchain. I'll recognize it when I see it. I think it was called Guillaume. Okay. Blockchain.com. Medium. think, let me just, Gulam, medium, article, tutorial. Smart contracts and so on. So we don't really want to. That's a bit beyond the what we want to. Maybe it was it Guishard? No. Anyway, it's not essential to this video. So let's I'm kind of showing it here because obviously many of us don't subscribe or have access to medium.com. I will demonstrate this code, but I'm not going to type it all in line by line and pretend that I've written it. That's disingenuous. And also, if you're just getting started, I think this may be, I say may, it may be confusing, or it may put you off, and I don't want to do that. So anyway, we've got the class, just like we've just looked at. We'll create a class instance and we'll pass the first argument itself, timestamp. So timestamp, transaction data, and then the previous block. And obviously the default is none because the first time you run it, there won't be a previous block. So we've got a hashing function here, which we've defined just here. So that's pretty similar to what I showed you just now. This particular one, so lines 9 down to 12, is only hashing it once. And this is because this is a tutorial. As we've read, Bitcoin will hash twice. That's not critical to what we're trying to learn at this point. Anyway, so what we're trying to learn is kind of the mechanics of it. So we're trying to learn about the three components, so which will gradually, well, not gradually, rapidly memorize, hopefully. So timestamp, transaction data, and previous block. Those three things. So there we go. That's the hash function, crypto.hash. And when you let's just get rid of that. And from crypto.hash import SHA. No, from crypto dot, and now you see we've got a choice of various things here. We've got cipher, hash, math, protocol, public key, random, signature. So yeah, we want hash from crypto hash import, and then sh. You start typing, and the one you want is SHA-256. If you go down, if you go to earlier ones above this, they aren't considered to be as secure. In fact, don't even know if they're secure at all, really. Let's just invest. Is SHA-1 secure? SHA-1 is as safe as anything against pre-image attacks. However, it is easy to compute, which means it is easier to mount a brute force or dictionary attack. The same is true for successors like SHA-256. I think SHA-256 actually takes more processing power, so actually it will be much, or I don't know about much slower, but it would be slower to brute force. SHA-1 be SHA-256. Remember, SHA is secure hashing algorithm. So different versions of SHA. Let's zoom in, hope you can see that a bit better. So there we go. SHA-224, 384, 512 differ due to different bit lengths of SHA-2. Okay, what's the difference between SHA-1, SHA-2, and SHA-256? So SHA-1, 160-bit hash values. So SHA-2 is a range of hash functions which includes SHA-256. Lastly, by 2015, due to vulnerability issues of SHA-1, it was phased out. And from 2016 onwards, it even became compulsion to make use of SHA-2 for all the newly issued SSL/TLS certificates. So SHA-2 basically covers 6 different hash functions with varying lengths. So yeah, just avoid SHA-1. SHA-256 is widely used. One of the variants of SHA-2 mostly used in today's date, including blockchain, SSL/TLS. So yeah, potentially could be brute forced, but the whole point of the blockchain technology is that it updates, and once it's updated, that is the current version, and it gets distributed to all of the nodes, and then it will change again. So it's a race to compute the answer between all of the nodes, and then once that's done, they're trying to compute the next one. So there's only a very small, very small space of time when you could try and brute force it, and trying to brute force something typically takes much time. Okay, so back to our code or code which I have modified it slightly, so it's not 100% as you would see it on Medium. So we do the hash. Here we're doing transaction data, timestamp, previous block. So those are our 3 inputs, and those are the 3 things which constitute or which will feature in any blockchain. The app property, so you've probably not seen me use this previously. It's used in object-oriented programming, and it's used when you want to pass a value from one method. So a method in object-oriented programming is a function inside a class. So if you've got a class and it's got a function inside of it, that's referred to as a method. Now, where you've got one method which passes its output, so we see line 25, this is actually being passed down here into the next method. Where this happens, rather than, you can see it's just passed as a variable. So you can pass it as a variable rather than actually calling the method itself. If we hadn't used the app property, we would have to be doing something like previous block cryptographic hash equals, and then we would actually be having to use this method with some pair of parentheses. No. We've also got it here. You can also use something called a setter. When you use the setter, you use the setter and then the name or with the name of the method. So setters dot setter, setter, Python at property. The problem is I'll just go back here. If we'd modified the value within the if we'd set a value within the init method, and then we relied on something from that down here in our next method, and then we changed it here. If we had another function that method here, it would actually still use the original value, and it wouldn't notice that this method had actually changed one of these initial values. So using a property just ensures that as stuff happens within your class, because a class actually will run from top to bottom and it will run these different methods. So it's a bit like your main block of code, really. It runs from top to bottom, and you want any modified values to be available to your next method. So at property in Python, I suspect real Python's probably, this was a good article which explains it quite nicely. If you go to machinelearningplus.com, there's a really good article. And what I'd encourage you to do is to fully understand what the app property does. Actually just copy and paste these examples into your favorite IDE, whether it's Sublime Text, Atom, VS Code, whatever. Run it, and then you can actually follow this tutorial and you'll see what the app property does. Right, so some tutorials for blockchain may feature this, some won't. I've left this in because I think it's a good thing to know and to learn and to have understanding of anyway. Right. This is the class, so line 14 down to 35. And what it's doing is it's taking, it's getting the timestamp, the transaction data, and the previous block. It's adding the previous block to the current block, it's creating a hash of it, and it's adding a timestamp. Actually, if any of you seen, I'm slightly tongue-in-cheek here, but if you go to YouTube, and I believe it's, I'm gonna have to show this really small, otherwise I'll probably get done for some sort of copyright infringement. It's called YouTube every programming tutorial. There we go. 12 million views, and it's 29 seconds long, and basically it's just it's a parody of every programming tutorial. I'll let you watch it. But yeah, watch it on YouTube. Every programming tutorial, and it lasts 29 seconds. Where were we? Let's just paste in this code then, so we don't want to be here all day, do we? In fact, if I just lost my, I'm just going to open up my GitHub page over here, and I'm going to paste in that code, and what I'm going to do is just demonstrate that code. It's on my GitHub. I've modified slightly from what was on medium.com, and just bear with me while I just try and find what I was. I'll bring it back across. There we go. Block 2, raw, Control A, Control C, and let's just paste that in and run. Yeah, so the class takes the time, hashes previous, return calculate hash. So it calculates the hash of the previous block, timestamp transaction data. And it actually performs that on the bytes, so it's not a string. Yeah, and those are our inputs. So we actually create 3 variables: timestamp 0, timestamp 1, timestamp 2. Then we've got transaction data with each of those, and then the previous block number. So if I run, so I'm just setting b2, a new variable, equal to, and then that's the class name, and then I'm just passing it the 3 things it needs. So, sorry, the camera's, I need to get a better camera mount, I think. It keeps moving, it's held together by sellotape. When I get some money from YouTube, I will excuse me, just doing some running repairs. It's not easy being a YouTuber. Having to drink tea and copy and paste stuff. I'm being sarcastic. The amount of hours it takes to make a 15-minute video, you wouldn't believe. And then if you do all your PowerPoint slides and do your little fancy, your comedy cartoons, and then you search for something on Wikipedia, a definition or something. Then you do a voiceover and you realize that you had the volume wrong, and then it's gone all distorted, and then you have to record it again. Or if you notice that you'd left your recording software on pause and you thought you'd unpaused it. Anyway, right. Let's run this. Error name, block is not defined. Block is not defined. Okay. Block equals, block is not defined. Last block. There we go. They didn't have any brackets around after the class name. Right. I'm just going to make that sidebar disappear, if I can remember how. I've customized my shortcuts in VS Code, and I've been using my laptop so long I've got used to the defaults. Do you ever do that? You customize so many things, and then when you go back to a vanilla machine, we don't want to show Alt D, right? Apologies for doing this on Windows. It's much better on. Anyway, it's a hardware issue, really. It's not software. Right. We've got a hash. So the hash is printed from line 62. Line 62 prints previous block cryptographic hash. And that comes from here, which comes from the previous block cryptographic hash. Probably the best thing to do is just, I've added this just to test it out. So yeah, create your own, modify it, and see what happens. Hash time previous block. If you don't remember anything else from this video, just remember those 3 things: the timestamp, the transaction data, which is hashed with SHA-256. And remember to use the SHA-256 as part of SHA-2, and don't ever use SHA-1. And yeah, just remember that you're adding the previous block to the current block, and then you're performing a hash on the products of that, or those two put together. So here we see block content is the transaction data and the timestamp and the previous cryptographic hash. Easy for me to say. So yeah, line 30 down to 32. That's, just remember that, transaction data, timestamp, previous block cryptographic hash. What this article was demonstrating was Albert pays Bertrand £30, euros, dollars, whatever. Albert pays Camille 10. Bertrand pays Camille 5. All of these actually build up, but they're all hashed. So what I just showed you was the hash of all of that. So error on line 20. What have I done? Don't ask me. I think it's because I've got Conda running here as well. Or it might have just been because I don't know. Perils of recording and demonstrating on Windows. Right, so I've covered machine learning, the article about the property decorator. If you want to see a tutorial without that, there are plenty out there. So don't think that you have to use the app property. But it's a good thing to learn anyway. If you want to generate random bytes, I found this site as well. So is it going to load? Yeah. Browserling.com, and you can generate random bytes should you need it. Generate random bytes. There you go. Output format hex. So let's go for binary. There you go. So if you want to generate random bytes, browserling.com. Okay, so I think as an introduction, this is probably enough. We've covered hashing. We've covered the app property decorator. We've covered SHA, secure hashing algorithm. And we have just looked at the Bitcoin wiki and discussed the difference between blockchain and Bitcoin. So blockchain is the technology that Bitcoin uses. So on that note, I'd like to thank you for watching. If this is not of interest, then sorry. But if it is of interest, drop me a comment and just say if you'd like me to proceed and do some more with this and actually code a blockchain from scratch, or actually look at other things such as the Merkle tree, or look at more things about cryptography and hashing and asymmetric encryption and so on. One of the best ways somebody ever explained to me, or that I read an explanation of encryption, public-private key encryption, was if I've got a parcel and I want to send it to a friend, I send this parcel to my friend with my padlock on it. So I send it to my friend with the padlock on it. The blue thing's the padlock. Okay. So I've got my key here for the padlock. When they receive it, when they receive the parcel, they just put their padlock on it as well, and they send it back to me. So now it's got two padlocks on it. And it's going across the public, it's going through public transportation. When I receive it, I remove my padlock, and then send it back to them. And I've obviously removed my padlock because I've held the key. So I send it back to them with their padlock on, and then when they get it, they've obviously got their padlock. They've got their key for their padlock, so they take it off. So the parcel has travelled in public, but the whole while it's always been locked. And that's how public-private key works. So just to run through that again, I send it with my padlock, they get it, and then they put their padlock on it. So now it's got two padlocks on. They send it back to me. I've got my key, so I take my padlock off. Then I send it back to them, and they've got their key for this padlock. They take it off. So it goes between me and them, me and them, and the whole time it's locked. And at no point, if we had to actually send any keys in the post or across the public internet. That's the analogy. I hope that's that I found that really, really it was just so much better when somebody had explained it as a parcel with padlocks. So this is my parcel. My padlock goes to the other person. The other person puts their padlock on it. They send it back to me. I take my padlock off. Then I send it back to them. They take their padlock off. So the whole time it's in transit, it's always got one or two padlocks on it, but no keys ever travel between me and them. Now that, as I say, that could be across the internet. It could be, it could be with a parcel delivery company, whatever. The padlock represents the key.